Good day! This video will be about acid-base properties of water. Water is a unique and universal solvent. It is so unique that it can behave as both an acid and as a base, and this is called amphoteric. It can also create ions just by itself, and this property is called autoionization. This process only occurs at 25 degrees Celsius. This is the equation of autoionization of water. Water molecule acts as an acid, and another water molecule acts as a base. Water also has its own constant, which is the ion product constant, also known as Kw. What is a base? A base is a substance that accepts a proton. What is an acid? An acid is a substance that donates a proton. In pure water at 25 degrees Celsius, the concentrations of hydrogen ion and hydroxide ion are equal, which have the value of 1.0 times 10 molar. These are the product of molar concentrations of hydrogen ion and hydroxide ion. Things to remember. When these concentrations are equal to the overall solution, it is a neutral solution. When there's more hydronium concentration, it is an acidic solution. And if there's less hydronium concentration, then it's going to be a basic solution. In here, I am writing the constant value of Kw. As Kw always has a constant value of 1.0 times 10 raised to negative 14 at 25 degrees Celsius. In getting the hydrogen ion, the equation would be this. And in getting the hydroxide ion, the equation would be this. In this problem, the formula that we will be using is this. Now that we know that the Kw's value is 1.0 times 10 raised to negative 14, we will be dividing it into the hydroxide ion, which is 0.010 molar. Now, you will get the answer of 1 times 10 raised to negative 12 molar. The unit will be always molar. Now let's move on to the next problem. Calculate the concentration of hydrogen ion in a solution in which hydroxide ion is 1.8 times to 10 raised to negative 9. The formula is the same as the first one. Now changing the hydroxide ion, it will be 1.8 times 10 raised to negative 9. And the answer will be 5.6 times 10 raised to negative 6 molar. Now on to the third problem. If hydrogen ion concentration in a particular acid is 2.5 times 10 raised to negative 3 molar, what is the hydroxide concentration? Now, the formula that we will be using in here is this. Now writing the value of hydrogen ion, which is 2.5 times 10 raised to negative 3. And the answer will be 4 times 10 raised to negative 12 molar. Now on to our last problem. The concentration of hydroxide ions in a particular household ammonia cleaning solution is 0.075 molar. What is the hydrogen ion concentration? The formula that we will be using is this. and changing this into the value of 0.075 molar. And you will get the answer of 1.3 times 10 raised to negative 13 molar. In determining what solution it is, you should look at the value of the hydrogen ion and the hydroxide ion. In problem number 1, the solution is basic solution because the hydrogen ion is lesser than the hydroxide ion. The value of hydrogen ion is 1 times 10 raised to negative 12, while the value of hydroxide ion is 0.010 molar. In problem number 2, the solution is an acidic solution because the hydrogen ion is greater than the hydroxide ion. The value of the hydrogen ion is 5.6 times 10 raised to negative 6, while the value of the hydroxide ion is 1.8 times 10 raised to negative 9. In problem number 3, the solution is also an acidic solution because the hydrogen ion is bigger than the hydroxide ion. The value of the hydrogen ion is 2.5 times 10 raised to negative 3, while the hydroxide ion is only 4 times 10 raised to negative 12. Problem number 4 is a basic solution because the hydroxide ion is greater than the hydrogen ion. The hydrogen ion is only 1.3 times 10 raised to negative 13, while the value of the hydroxide ion is 0.075 molar.